Hi there and welcome to another video from Hegartymaths. It's Mr. Hegarty here and this is video 26 on box plots. Just a reminder, you'll find this in the Secure Grade C GCSE section of the website and how you're supposed to use these. These are mainly to quickly refresh a topic, not teach it from first principles. You take the notes down of the refresher and then you pause the video and try the exam questions that come up afterwards. After you've tried them, you play the video and you mark your work and see whether you understand it. If you're logged onto the website, you can therefore track your progress by this. So in this video, we're doing box plots. Now, I'm going to just quickly tell you the 3 questions the examiner usually likes to ask. Now, box plots can usually be for 4 marks. They're linked to the cumulative frequency video 25, so it's important you've watched that before you do this one, because sometimes both of these questions come up and together they can be worth about 10 marks. They can be in different papers. So the questions they ask the following. They may give you a list, and they may get you to give you a list and draw the box plot. Okay? They may give you key or important piece of information and get you to draw the box plot and get you to draw the box plot, and I'll explain what information that is in a second. Or lastly, from what we did in video 25, the cumulative frequency diagram, and I'm going to write here video 25, they can get you to draw the box plot, get you to draw the box plot. And actually lastly, there's one other thing they can do. They can get you to compare what they say are distributions by comparing the box plots, by comparing two box plots. So I'm going to try and cover each of those in this video. Now, I'm going to briefly introduce you to these ideas and then we're going to do some exam questions. Okay, first one. Imagine I gave you a list of data items. Just say this, I don't know, this was something like the number of pages of a book a girl reads. So something like number of pages of a book a girl reads a night. A girl reads a night. And this one's the exact same, but the number of pages maybe the boys read at night. Number of pages some boys of a book. A set of boys read each night. Okay, here are the data items. Now what we do is we have to identify the smallest. So 3 is the smallest and the biggest is 20. We need what's called the median and the lower quartile and the upper quartile. So the median happens like this. The median is the middle number, so it's not the first, not the last. By the way, these have to be in order. If they weren't given in order, you put them in order first. Not the second, not the second last, not this one, 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 not this one. So the median here is 12. So we would call this the median. Now the lower quartile is the middle of the lower end. So it's the middle of these. So it's not this one, not this one, not this one, not this one. It's the 6, the one on its own, the lower quartile. And the upper quartile is not this one or the end one, not this, not this. It must be the 17, the upper quartile. And what we can do is we can plot them on here. So we put a little dash by 3, the smallest. We put a little dash by 20, the biggest. We put a dash by the lower quartile, which is at 6. Put another dash by 12, which is the medium, and another one by 17. And we draw a box plot. So between the lowest and the lower quartile, you draw a line, and you just have a little end point like that. Between the biggest number and the upper quartile, you draw another line and a little end point. And then you draw a box. So a box from the lower quartile all the way up to the upper quartile as follows. And somewhere in the box where the median is, you draw a line up like that. And that's what a box plot looks like. So this again is the smallest, that's the lower quartile, this one's the upper quartile, this one's the biggest, and this one's the median. And what you'll notice is, and something really important to notice, is the length of the box, the length of that whole box is the upper quartile take away the lower quartile, which we call the interquartile range, which you will have seen in video 25. So the length of the box is the same as the interquartile range. The length of this box from 6 to 17 is 11, so the interquartile range is clearly 11. So that's that one. Let's draw the same thing with the boys. Now, let's find the smallest numbers here, the biggest numbers here. So the smallest, I'm going to put a dash at 0, and the biggest, I'm going to put a dash here at 15. Then we're going to find the median. So remember, not this one or this one, not that one or that 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 one, as long as they're in order. So it's 7. So we're going to put a little dot here at 7. And that's the median. And to find the lower quartile, it's the middle of these green numbers here. So not that one, not that one, not that one, not that one, it's that one. So the lower quartile is 2, a little dot at 2. And the upper quartile is the middle of these green ones, not that one, not that one, not that one, not that one. It must be this 11, that's the upper quartile. So at 11 is the upper quartile. Now remember, we draw a little line from the lowest to the lower quartile and a dash, and from the upper quartile to the biggest and a dash, and then we draw a box as follows. From the lower quartile to the upper quartile and a line where the median is. Now remember, this here is going to be your smallest, this is your biggest, this is your lower quartile, this is your median, and this is your upper quartile. And remember, the interquartile range is the length of the box, so the length from 2 to 11, i.e. 11 take away 2 is 9. The box is 9 long, and that's the interquartile range. Now, here is a picture showing the amount of books a girl reads in a night, pages of a book girls read in a night, and here's the one for boys. And we are often asked to compare the distributions of boys versus girls, or whatever we are comparing. And you must always say two things, and you separate them out. You say one thing here, and you get a mark for it, and you say a second thing here, and you get a second mark. The first thing we're going to do is we're going to compare the medians. So we're going to compare the median of the girls versus the median of the boys. The median of the girls is 12, the median of the boys is 7. So we just have to say a statement, the median of girls is bigger, so on average the girls read more. The girls read more pages. Simple as that. And the next thing we're going to do, we always have to do this, is compare the interquartile range. Now the interquartile range is the length of the box. The length of this box, we said, was 17 take away 6, which was 11. And the length of this box is equal to 9. So clearly the girls' length of box, the interquartile range, is bigger. So the interquartile range of girls is bigger, and this is the key phrase you must say. So the girls' results are more, and you must use this phrase, spread out. So when we're comparing, we compare the medians, say which one's bigger, and say on average one's bigger than the other in the context of the question. And for the second mark, we see which length of the box is bigger, and therefore we say one of the interquartile range is bigger than the other, so those results are more spread out. Okay, so that's the first thing. Learn this. This almost comes up regularly, very regularly. These 2 marks you can gain easily, and draw in the box plots as follows. Okay, another example here. Imagine you were given the key information and you're asked to draw the box plot. So what do we need to draw a box plot again? We need the lowest, okay, we need what's called the lower quartile, we need the median, we need the upper quartile, and we need the biggest, don't we? Now, sometimes they give you some of these, but not all. They've given us the lowest, they've given us the highest, they've given us the median, they've given us the lower quartile, but they haven't given us the upper quartile. They've given us something else, the interquartile range. Now remember, the interquartile range is the length of the box. We've just got to remember that. So we can find the upper quartile using that. So let's plot this information. The lowest mark is 8. There are 5 squares worth 10, so each is 2. 2, 4, 6, 8. We put a little dot there. The highest is 94, so 90, 2 and 4. We put a dot here. The median is 68, so 62, 4, 6, 8 is about here. The lower quartile is 40, so it's about here. Now the lower quartile is 40, the length of the whole box is 36. So if we go 36 from 40, we'll get the upper quartile. So 10, 20, 30, and 2, 4, 6. There we go, the upper quartile is there. And how do we find it again? So the upper quartile was the lower quartile plus the interquartile range. It was equal to 40 plus the 36, which is 76. It was the length of the box. So then we just draw our diagram as we're used to. Like that. And we've drawn it, and we'll label it at the end. We'll label this the lowest, the biggest, the lower quartile, the median, and the upper quartile. Okay, so just remember here, this we were given this, we were given this, we were given this, and we were given this. We did not have this one here, but we found it because the IQR is the length of the box. I know the box is 36, so I just counted 36 up from 40 to get to 76. And that's the second style they ask it. The last way they ask it is they either get you to draw a cumulative frequency diagram. So this here, it wasn't a frequency table, it's a cumulative frequency diagram. So they get you to draw a cumulative frequency diagram, or they give it to you, and they tell you here it's about 60 teachers, the ages of 60 teachers, and then they'll tell you the youngest teacher is 21, the oldest is 67, and they'll get you to draw a box plot. So remember, you need the smallest, which they give you is 21. You need the biggest, which they give you 67. But we're going to need the lower quartile, the median, and the upper quartile. We can get all of these from cumulative frequency. There are 60 teachers. The median happens at 30. So what we do is we'll draw a line across from 30 till it meets our cumulative frequency, read down, and we look like we get about 41. Each square along here is 1, each square here is 1. So 41 or 2 is the median. Now, how do you get the lower quartile? So the median is 41. How do you get the lower quartile? Well, it's the middle of here. So it's the middle between 0 and 30. You'll see this on video 25, which is 15. So 1, 2, 3, 4, 5. You draw a line from 15, a line down, and you look like you get 32. And that's your lower quartile. So you can go here and say your lower quartile is 32. Go back to your picture. The upper quartile is halfway between 30 and 60. So halfway between 30 and 60 is at 45. Draw a line across, read down, and you get yourself 50. So 50 is your upper quartile. Go back here and write 50. Now all we've got to do is draw the picture. The smallest is 21, so 21's here. The biggest is 67, so 61, 2, 3, 4, 5, 6, 7, about there. The lower quartile is 32, so 30, 1, 2, there. The median's 41, 40 is here, and 1 would be here. And the upper quartile is 50, and there we go. And then, of course, we just draw the thing that we're used to, so just like that. And then we draw our box. And there's the median. And we'll label it up. We'll say the smallest, the biggest, the lower quartile, the median, and the upper quartile. Just out of interest, if anyone asks you the IQR, it's the length of this box. The IQR is the length of the box. And from 32 to 50, well, we could just do 50, take away 32, which is equal to 18 years old. Okay, and that's basically everything they can ask you about box plots. Now it's time for you to pause the video. You can print out the worksheet from the website and you can work through the worksheet like that, and then afterwards, when you've done all the questions, unpause it, mark all your work, and on the website highlight your understanding green, amber or red. So here's the first question. It's 2 parts to it. Okay, I'm going to go through these in 5 seconds, so pause if you want to now and work your way through. Okay, so here are the times of 15 people in the Rose Garden Centre draw this information. So to draw this, we're going to need the smallest, we need the lower quartile, we need the median, we need the upper quartile, and we need the biggest. The smallest is 5, so we'll write that. They're in order, luckily. The biggest is 44. So we need to find the middle first. So let's find the middle. So not that, 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 not that. It's this one here on its own, 25. So the median is 25. Now the lower quartile is the middle of these numbers. So it's not the first, not this, not this, not this, not this, not this. It's this 14. So that's that. And the upper quartile is the middle of the yellow, not this, not this, not this, not this, not this, not this, that one there. So it's 30. And all we've got to do is plot the thing now. So the smallest is 5, each little square is worth 1, so the smallest is 5 there. Then we've got lower quartiles 14, which is about here. The median's 25, which is here. The upper quartile's 30, which is here. And the biggest one is 44, which is there. Then we just draw our diagram. So, like that. There we go, there's our box plot. Let's label it up. That's the smallest, that's the biggest, that's the lower quartile, that's the median, and that's the upper quartile. Okay, so 3 marks, nice and easily collected. Then it says the box plot shows the distribution of times people waited at Green's Garden Centre. So we previously drew the box plot for Rose's Garden Centre, and now they've drawn it for Green's. And they've said, look at this, the classic phrase I said would come up, compare the distribution of times people waited at Rose's versus the ones they waited at Green's. 2 things you've got to say. I'm going to put 1 and 2 just so you know that you write them in different sentences, not all together. The first thing, we're going to compare the medians. The median here is 25 and the median here is this one here, which is 21. So the median, so we can say the median at Rose's is bigger. And what does that mean? We have to state what it means. So on average, people wait longer at Rose's Garden Centre. Okay, wait longer to be served. Now the next point, we have to compare the interquartile range. That's the length of the box. So we have to compare the length of this box, the interquartile range. It's between 14 and 30, so it's 16 long. This one here, how long is this box? Well, it's between 12 and 35. So to me, it looks like 8 and 18. It looks like about 23 long, so it's definitely longer. Look, that box is longer than that box. So we can say the IQR, we can shorten it to IQR of this one, Greens, is bigger this time, of Greens is bigger. And we have to state what that means. So their waiting times, i.e. their results for their waiting times, are more, and do you remember the phrase? Spread out. Done. 5 marks secured. Okay, next question. Starts there, and I would like to pause the video and work through it. If you're not on the worksheets, I'm going to go through in 5 seconds. Right, so this one, it tells Samina recorded the time in minutes some girls took to do a jigsaw, and here are her results. She's got the shortest, the lower quartile, the median, the upper, and the longest. Everything to draw a box plot. And they ask us for 2 marks to draw the box plot. So, be super careful here to see our scale. There are 10 squares worth 5, so each little one can't be 1 because it'd be 11, 12, 13, 14, 15. So each 2 squares are worth 1. Look, that must be 11, that must be 12, that must be 13, 14, and 15. Be super careful. So here, 2 squares worth 1 minute. So be super careful there. So 18. So it's the shortest 18. So 16, 17, 18. 18 looks like it's there. 25, well that's lucky, it's dead on the line there. 25 for the lower. 29, so 26, 27, 28, 29 looks there. 33, 30, 1, 2 and 3 there. And 44 would be 41, 42, 43, 44. Be super careful not to count 4 squares there for 44. You have to be really on the ball here to get these. So draw the picture. Line there, line there, line there, line there. Like that. And there's our box plot. And hey presto, look at this again. It's coming up each time. Compare the distribution of girls versus boys. Because below it shows you how long it took some boys to do the same jigsaw puzzle. And they've got a diagram there. So we've just got to compare these. Now, I've told you about this before. 2 things to say. Write 1 and write 2 so that encourages you to keep them separate. Firstly, compare the medians. The median here is 29. The median here looks like it's 25 and a half. So clearly the median of this one was the girls is bigger. So we write that. The median of girls bigger, and we have to state what that means. So on average, girls took longer to do jigsaw, And what do we do for the next part? We have to comment on the interquartile range, which is the length of the box. The interquartile range here and the interquartile range here, the length of the box. Well, I think it's pretty obvious to see that this one's probably a bit longer because it seems to be going from 19 up to 25, which is 19, sorry, up to 26, 27, 28. It seems to be about 9 long, whereas this one is not 9 long, it looks less than 9. So this one looks longer, so we can state that the IQR of the boys this time is bigger, and so we can state what that means. So the IQR of the boys is bigger, so the boys times are, and what's the key phrase? More spread out. Okay, and that's the next question done. Let's try the next question. So here we go. You can pause the video and work through it if you're not on the worksheets, but they're on the website. I prefer that. I'll go through in 5 seconds. Okay, we've seen this question when I taught you it in the start. So to draw a box plot, what do you need? The lowest, the lower quartile, the median, the upper quartile, and the biggest. We have the lowest, we have the highest, we have the median, we have the lower quartile, but look, we don't have the upper quartile. But we can work it out because the interquartile range is given, and that is, if you remember something about the box, it's the length of the box. Okay, so that's enough information for us to be able to plot this. Now, the 5 squares are worth 10, so they must go up in 2s. 2, 4, 6, 8, 10. Yeah, they do. So let's mark 18. 18 must be 12, 14, 16, 18. 18 must be here. Highest is 86, so 82, 4, 6 must be about here. The median is 57, so 50 say 50's here, 52, 54, 56, and halfway in a box then it's 57. The lower quartile is 32, so 30, 32 is there. So what have we got so far? Let's just plot what we've got so far. Okay, we've got that amount so far. Now, but what we don't have is the upper quartile. But we know the length of the box is 38. So we know we've got to draw a box 38 long. Now, if we're starting at 32, 32 add 38 must end at 70. So if you want to check, 32 add 38 ends at 70. So they must be 70. So the upper quartile must be at 70, which is there, and we can therefore fill it in as follows. And that's our box plot, and we're done. So it should just label it up. So the lowest, the biggest, this was the lowest quartile, the median, and the upper quartile, and we're done for nice 3 marks. Okay, next question. There's the first part. You may pause the video and have a read through. And the rest of it is here. You may pause the video and read through. I'd encourage you to print the worksheet out from the website. I'll go through this in 5 seconds. Okay, so what have we got here? We've got Harry growing tomatoes. This year he puts tomatoes into 2 groups, Group A and Group B. He gives fertiliser to the ones in Group A. He doesn't give fertiliser to the ones in Group B. He weighed 60 tomatoes in Group A, and below is the information about that. So this is Group A's data. Now just think, before you even launch into the question, he gave fertilisers to Group A. You'd expect them to be bigger, right? Because they help them grow. You'd expect the ones in Group B without fertiliser, therefore, to be smaller. So let's see if that pans out in the question. What does the question say to us? Well, to start with, part A, use the graphs to estimate the median. So let's think about this. We have got 60 tomatoes. The median must happen at 30, which is midway through. So the median must happen here. We draw a line across from 30 to our cumulative frequency curve, and then down, and we read off that therefore the median must be 170 grams. So we can highlight that as the median, and we can state here it's 170 grams. Okay, next part. It says the 60 tomatoes in Group A have a minimum of 153 and maximum of 186. Use the information and the cumulative frequency graph to draw the box plot for Group A. Okay, the box plot, what do we need? Well, we need the smallest. They gave us the minimum. We need the lower quartile. We don't have that. We need the median. We worked that out in part A. So we have the median. We worked that out in part A. The smallest is 153. The median is 170. The upper quartile we don't have. But the biggest, i.e. the maximum, is 186. And we do have. So we need to work out the lower quartile and the upper. But we can go back to the graph and use the graph. The lower quartile must happen between 0 and 30, halfway, which is 15. So we draw a line across here and down, and it's 165. So here we would say 165, which would be the lower quartile. And the upper quartile happens halfway between 30 and 60, which is at 45. So we draw a line across here from 45, and then read down, it's at 175. So 175 here, which would be the upper quartile. So we go back here, and we know the lower quartile we said was 165. So 165. The upper quartile from the graph is 175. And now we've got everything to plot here. Now we've got 10 squares and they're worth 10. So we can just plot nice and easily. 153 is here. 165 is here. 170 is here. 175 is here. And 186 is here. And then we just plot it like normal. So line here to here. A line here to here, and then we draw a box with our median marked at the right point. And this is our smallest, our biggest, our lower quartile, our median, and our upper quartile for Group A. Okay, Harry did not give a fertiliser to tomatoes in Group B. He weighed 60 tomatoes from Group B. Here are his results. Oh look, the same old question that I predicted. Compare the distribution of weights of tomatoes in Group A with the distribution from Group B. 2 things we must say. write 1 down here, write 2 down here. You've got to compare the medians. The median of this is 170, the median of this looks like 162. The median of group A is bigger than the median of group B. So the median, we can say, of group A is bigger, okay? So what? What does that mean? So on average, we must state, tomatoes in A are bigger, okay, or way more. Now, what do we do for our second part? We've got to compare the interquartile range, which is the length of the box. This box here has length 10. This box here is going from 1, 5, 8, 9, so 1, 2, 3, 4, 5, 6, 7, 8. It's only 8. So this box is wider, is longer. So we can state for the second part the IQR of group, which one is bigger? A is bigger. Okay, we state that. So what? So the tomato sizes in A are, and you have to state this, more spread out. Okay, and we're done there for the remaining marks. Okay, next question. Have a look. You may want to pause the video. There's your diagrams that you have to draw on this here. And if you're working through the worksheet, just work through it. I'll go through it in 5 seconds. Okay, we have that 80 students took a maths exam. They sat 2 papers. Here is the cumulative frequency table already done on paper 1. On the grid opposite, draw this. So what are we going to plot? We don't have to draw the cumulative frequency table here. It's done for us. We're plotting those against those. So let's just write down our coordinates. We're plotting 10 with 8. We're plotting 20 with 21. We're plotting 30 with 46. We're plotting 40 with 67. We're plotting 50 with 76. And we're plotting 60 with 80 as follows, right? So we're going to plot that for 2 marks on this grid. So I'm going to go over to the grid here and I'm going to plot that. Okay, so there's 10 squares here, each worth 1. So they're worth 1 each, so that's good. And similarly up here, they're worth 1. So that's the ideal scenario, nice and easy to plot. So what are we going to do? Let's plot 10 with 8, 10 across, 8 up, 20 across, 21, 30 across, 46. So 1, 2, 3, 4, 5, 6 there. It's 40 with 67, so 40 with 1, 2, 3, 4, 5, 6, 7 there. 50 with 76, 50 with 1, 2, 3, 4, 5, 6. And lastly 60 with 80, like that. Join the dots. That, and we could even join that dot back to the start if we want. So there we go, we have drawn the cumulative frequency. Now, then they tell us that the lowest mark on paper 1 was 9, the highest mark was 52. In the space provided, draw the box plot for paper 1. So we're going to go over here. We've got a space provided for the box plot for paper 1. What do we need? We need the lowest. We need the lower quartile. We need the median. We need the upper quartile. And we need the biggest. Now, what data do we have? We're told the lowest was 9 and the biggest was 52. So the lowest was 9 and the biggest was 52. We don't have any of these here, but we can use the graph. We know that there are 80 students, yeah? So the median happens at 40. The lower quartile must happen halfway between 0 and 40, which is 20. And the upper quartile must happen halfway between 40 and 80, which is 60. So let's just draw some lines across. The median, draw a line across here. Read down. That looks to me like 28. So the median here is 28. Let's go for lower quartile next. Go across from 20 and down. It looks like 19 to me. So the lower quartile is 19. And we'll go over for the upper quartile. Go up across at 60. Go down. It looks like 47 to me. So 47 there. So we've got all the information we need to draw this diagram. The lowest is 9, so put a dot at 9. The biggest is 52, so put a dot at 52. The lower quartile is 19, put a dot there. The median is 28, so put a dot there. And the upper quartile is 47, so we're going to put a dot there. Then we're going to draw this diagram as we're used to now. Like that. A bit more careful than me, just a little bit more careful there than me. But that's all looking fairly good, and there we go. So, going back here, we have for 3 marks drawn the box plot. Now lastly, the same old question. There is a box plot drawn for the ones in paper 2. Compare the marks in paper 1 with paper 2. Always 2 things to say, 1 and 2. Look at your box plots. Ooh, look at your box plots there. This median here is 28 and this median here is 32, so the median's bigger on this one. Which one's longer? Well, this one here looks longer. It's very obvious. We don't have to state it, but that one's clearly longer. So for the first mark, we're going to state that the median on paper 2 is bigger. So we're going to state that the median on paper 2 is bigger. So students, on average, did better on paper 2. And the next one, we're obviously going to compare the interquartiles. Now clearly the interquartile of paper 1 is bigger, the width of the rectangle is bigger, so the IQR on paper 1 is bigger. So paper 1 results, and what's the key phrase? Are, see if you've got it now, more spread out. Okay? Okay, and the last question then, this is the last one, so there's the first part, there's the second part, and the third part. I'd advise you to print these out. Okay, pause the video and go through. I'm going to go through it in 5 seconds. Okay, so we've got a cumulative frequency graph. It's about 80 swimmers and it's how long they took to swim 50 meters. Okay, use the graph to estimate the median. So if there are 80 swimmers, the median must happen at 40. So we draw a line across from 40 to our graph, read down here and read this off. Now, be careful, there are 10 squares worth 20, so each square must be 2 because this must be 70 midway between. So this is 68, 2, 4, 6, 8. So the median is 68 seconds. A swimmer has to swim 50 meters in 60 seconds or less to qualify. So they have to be less than 60 seconds to qualify. The team captain says more than 25% of the swimmers did qualify. Are they right? Well, 60 seconds or less. Let's go to the graph. Let's draw up from 60 seconds and let's read across. It looks like to me that the people that did it in less than 60 seconds are, because we're looking at less here, must be equal to 27 people. So from the graph, so you can say from graph, 27 people swam 50 meters in less than 60 seconds, okay, which is more than 25%, more than 25%. So the captain's right. Okay, and how do we know it's more than 25%? We could just state in brackets 25% of 80, which is a quarter of 80, so you can half it and half it again, would be equal to 20 people. So obviously 27 is bigger than 20. Okay, and the last element of this, it says for these 80 swimmers, the least time was 28, the biggest was 96, draw the box plot. So we've got the smallest, which was 28, we've got the biggest, which was 96, we've got an estimate for the median, because we did it in part A, I think, and we said it was 68, but we need the lower quartile and we need the upper quartile. So we're going to get these from the graph, go back to the graph. The lower quartile happens halfway between 0 and 40, which is 20. Draw your line there, draw it to here. It looks like this must be equal to, that point there must be 50. So it looks like 52. So we're going to go back here and call that 52. And going back to work out the upper quartile, halfway between 40 and 80 is at 60. Line from 60, line down. It looks like to me, if that's 70, 2, 4, 6, 2, 4, 6. So it looks like 76 for me. So I'll go back here and I'll say that's about 76. And then we'll just plot these. So 28, so just, let's maybe draw on this line. 2, 4, 6, 8, there we go. 52, 50 is here and 2 is here. That must be 50 obviously. 68, well 62, 4, 6, 8 there. 76, well if that's 70, 2, 4, 6 would be there. And 96 is here, so if that's 90, 2, 4, 6 there. And we just draw it in like we used to, just like that. We'll draw a box here. Done. And there we go, that's every type of question that's come up on box plots and linking with cumulative frequency. Hope you found that useful. Thanks loads for watching.